So here we go. So we are in chapter 6. This is where Math 63 will start off, right? Right in the beginning. It'll start with chapter 6. This is the one chapter that overlaps in the two courses. They just overlap this one chapter. Okay, so they're asking me to factor. Now, what is factoring? Factoring is... Yeah, it's breaking it down. It's multiplying backwards. It's unmultiplying. In other words, they're saying, hey, there was a couple of things that were multiplied and they became 5x plus 20. What were they? That's what they're asking. They're saying, what was it before it was multiplied? In other words, there was something on the outside, there was parentheses, and there were two things on the inside with a plus sign. What were those things? That's what they're asking me. Does that make sense? What we're doing there? So there was something on the outside, and it multiplied, it distributed, right, to become 5x plus 20. What was it? So I'm supposed to think the multiply backwards. Yeah, so how do you figure it out? Well, you figure out first off what's called the greatest common factor, which means what's the biggest number that goes into 5 and 20? What goes into 5 and into 20 evenly? 5. 5 goes into itself and into 20. Well, that's what you put on the outside. Whatever goes into both of them. So that's how you find the number in the front. That's called the GCF, or the greatest common factor. It's the biggest number that goes into 5 and 20. Okay, so then how do you figure out what goes on the inside? Whatever works, huh? Just say 5 times what would go back to 5x? X. And 5 times what would go back to 20? And we're done. See how we just thought the multiplication backwards? That was not bad. They'll get much more challenging than that. Is that good? Does that make sense? So far, so good. All right, let's try that one. Factor out the GCF. Same kind of thing. So we have two terms. Well, it's a little different because it's mainly letters. So when you look at the two terms, do you know, so we're going to do the same kind of thing. We're going to have something in the front, parentheses, two things on the inside with a plus sign. So, well, how do you know what goes in the front? Well, what it is when they both, they don't have any numbers in common, huh? There's not like a 24 here and an 8 there. Then I would say, hey, 8 goes into both those. But there's no number that they both have, so we don't have to worry about that. It's not like the last one where there was a 5 and a 20, so we said, oh, 5 goes into 5 and 20. There's no number at all in the front one. So we're just looking at the letters, and they both have letters. Which one should we put in the front, the x cubed or the x squared? Well, we should do the GCF, which is the greatest amount they have in common. What does that mean? So what if I say, Shelby, how many coins do you have in your purse there? And she looks, and I look at how many coins I got in my pocket, and I say, Shelby, do you have at least one coin? She goes, yep, I got at least one. Suppose she's got 3 and I got 2. And I go, Shelby, do you have at least 2 coins? And she goes, yep, I got at least 2. Notice we have 2 in common. I say, and I say, Shelby, do you have 3 coins? And she goes, yep, I do. And I go, I don't. So what's the most we have in common? 2 coins, right? So the greatest amount 2 things have in common is actually the lower number. That's kind of weird, isn't it? Because you think greatest, I can take the bigger one. But it's greatest in common. Make sense? The most they share, the most in common is 2 x's. They both have 2 x's. That making sense? They don't both have 3 x's. So the most they have in common is 2. So you take the lower power. You take the lower one. So it's going to be x squared. So when it comes to powers, you actually take the lower number because that's the most they have in common. Okay, now, the rest is easy, right? It's just whatever works. X squared times what would go back to x cubed? Just regular x, because that's invisible 1 power. Powers add, we know all those rules, huh? Because we did it forwards. And then x squared times what would go back to 8x squared. Just the 8, and we're done. There it is. It's x squared, parenthesis, x plus 8. I kind of scribbled it all up. It's just going to be x squared, parenthesis, x plus 8, like that. We good? Easy enough? Want to try number 3 there? Here, let me make number 3 a little bigger. Okay, so try to use your calculator. So it's going to be 2, because 2 is the number it's the biggest number that goes into 32 and 98 evenly. Both of them divide by 2. And then what are you going to do when it comes to the letters? You're looking at xy and x squared, and you're supposed to put in the front what they have in common. What do they both have? Just x, huh? Remember, you take the lowest power of what they have in common. The lowest x, he has an x and he has x squared, so the lower one is just regular x. Put a parenthesis. Good so far? That makes sense? So I don't take the x squared, I take the x, because that's the lower one. Remember, for the powers, you take the lower power. So now put inside whatever works. Just use your calculator if you're not sure. Find out what would multiply to make it work. So 2x times what? 16y. Because 2 times 16 is 32. X times y is xy. You good? And 2x times what? Would go back to 98, but it's a minus in the middle, huh? Minus 49x. And there we go. What are we doing? We're unmultiplying. Why would anybody want to unmultiply things? There's no reason. It's just something for algebra students to do. I'm just kidding. There's all kinds of real life engineering and science reasons why people do these kind of things. All right, we good there? Questions on that one? Gateway to everything else in higher math. So this is the gate that leads to higher math. Factoring is super important. All right, now let's try that one. Now we got 3 terms, same deal. Same deal. Look at those 3 terms, take out what's in common. So start with a number. Find a number that goes into 16, 10, and negative 18. So again, it's 2 and x in the front. 2x. And then what goes inside, we're going to have 3 things inside this time with a plus sign between the first 2 and a minus sign between the last 2. So 2x times what will go back to 16x to the third? 8x to the second. Remember how it works? There's an invisible 1 power on that guy, huh? So remember, you're checking by multiplying them back, right? You're saying the out front numbers multiply, powers add. 2 times 8 would be 16. Powers would add to go back to x to the third, huh? That's why we want to learn it forward. Now we can do it backwards. 2x times what goes in the middle, will return to 10x squared. 5 and regular x, which means 1 power, the powers that add go back, huh? And 2x times what would go back to minus 18x? 9. Just 9, not 9x, huh? Why would it be wrong to go 9x? Because that 1 power would add to the 1 to go back to 2, and it's not 2. So, yeah, it's just the 9, and there we go. Is that good? We good with that? Questions? Okay. Getting the hang of this? All right, try number 5. Take out what's in common. What goes into all those? Right, yeah, so 2. Wait, I don't know if I have room here. All right, 2. Yeah, do they all have an x? Yes, they do. You take the lowest one, that regular x. And then what about y's? Do they all have a y? Yep, so you just take the lowest one, which is y. Okay, like that. And then we're going to have 3 things on the inside, plus between the first 2, plus between the back 2. And we just multiply whatever works. 2xy times what would go back to 2x cubed y? X squared. Because the 1 power and the 2 power will add. Good. And then 2xy times what will go back to 16x squared y? 8x. Right? Because the 1 powers will add. And then 2xy times what will go to 18? 9. Just 9, huh? Don't even need an xy because it's already coming from the 2. Isn't it? 2xy. Boom. And we're done. That good? This makes sense how we're factoring, multiplying backwards? Unmultiplying, or whatever you want to call it? Good? So please speak up if you're on this is super, this is the most important chapter we've done. Like I said, it's the gateway to everything else. All right, so number 6 there. So now we got fractions. There's 4 terms. So when you factor out what's in common, notice they all have a 6 on the bottom, huh? So for sure going to be a 6 on the bottom. And what's in common with the numbers in the top? No. Just 1, huh? 1 goes into all of them. So 1/6 is the number, is the fraction that goes into all of them. Is that good? And now, what about the x's? Which power of x do you take out? The lowest one you see. Remember, for the x's, it's always the lowest, which is just regular x. So 1/6 x. We good? So that's the GCF. The greatest amount in common. So now what goes on the inside? 4 things. 1, 2, 3, 4. So plus sign between the first 2. Minus sign next 2. Plus sign back 2. All right, here we go. So just make it work. So 1/6x times what? We go back to 1/6x to the 5th. X to the 4, because the x1 and x4 will add to be x5. Right? It's already got the 1/6. So far, so good? 1/6 x to the 1 times x to the 4, the powers will add to be x to the 5. Good. Are we happy? And then 1/6 x to the 1 times what? We'll go back to 5/6 x to the 7. 5x to the 6th. Does everybody see that? Why will that 5 go to the top? Because it's over 1. Like anything alone is really over 1. Remember, to be alone is to be in the top, because you're over 1 really. So that 5 will go to the top, and x6 and x1 will add to be x7, won't it? See how that's working? You good at thinking this backwards, getting the hang of this? Try the next 2 parts of it. Can you finish up the rest? So, what comes? We got to multiply to get minus 7, 6x6. It'll be a 7x to the 5th power to add to the 1 to be 6. Good? And then last spot. Good. We do need a 1, don't we? It's not 0, it's 1, huh? Everybody good there? Because 1x to the 1/6x times 1 will be 1/6x. Remember, we're multiplying. We're multiplying backwards. We're sort of thinking about multiplying, right? We good on that one? Is that okay? Questions I can answer? So that 1 thing will come up a lot where we have a 1 at the back like that. 1/6x times 1. All right. So what if you had 7x, or no. What if you had yx minus 3x? Let's try that. What if you had yx minus 3x? How would you factor that? Could you do that real quick? Let me let you do that. Go ahead and factor that one. Factor, equals, it's going to be something in the front, parenthesis, 2 things on the inside. Can you factor that one? Okay, so what do they have in common? What's their greatest common factor? What do they have in common? What do they share? X, yeah, just X, huh? So what goes in the inside? Well, clearly, you know, boom, boom, it's going to be y, and not plus but minus, huh? Minus 3, right? That's simple. You guys are like, you do that easily, right? So notice what I did. I just removed the x, because that was in front, common, and then just wrote down the y minus 3, didn't I? Do you see the pattern? See the pattern? Because they're going to make it bigger now. So in other words, the pattern is this. If what if instead of x we had yw minus 3w? What would I do? Same thing. What do they have in common? W. Start a new set of parentheses. Remove it in a sense because it's already in the front now, and it just leaves y minus 3, right? Because that can multiply and go right back, right? Okay. With that in mind, now let's do number 7. Number 7 says y x minus 9 minus 3x minus 9. Do you see that that's the same exact thing? They're just making it bigger. It's exactly the same. It's not really different. What do I mean? This part is like the WW or the XX. They're just trying to make it bigger to throw you off. But do you see that the pattern is the same? Math is patterns. That's it. Math is the science of patterns. See the pattern? The pattern is if you have matching pieces, whether they're just a little w or a big old parenthesis x minus 9, whatever, what do? When you go to factor? You put that item they have in common. Isn't this what they have in common? Put it in the front, remove it, because now it's in the front. Start a new set of parentheses. Write down the leftovers. What's left over? Y minus 3. See how that's exactly the same, but we're just doing it with a bigger thing than a smaller thing? They're trying to throw off your eyes with the extra parentheses and all that. Do you see the pattern there?
That makes me want to distribute it.
Yeah, if we FOILed this out and FOILed that out, they are the same. They are the same. But you can see it most clearly by imagining this whole big thing as an inseparable chunk going there and there. That confusing? I'm probably confusing you. You don't normally think of multiplying that way, I know. But, yeah, how about I not? I didn't say that. So nothing happened there. All right. So is that generally good? Do you see the idea? See how this is the same? Just like the W's are the same, you put it in the front. So these are the same, I put it in the front. Remove it, write down the leftovers, y minus 3. Did y'all see that? See what happened there? All right. Minus 3x minus 12. Let me make it a little bigger. Well, it's okay, you can see it. Factor out the... So, same kind of thing, I'm still factoring. But they want me to factor a negative number out. So, when I look at these two, there's nothing in common. Oh, no, there's 3. Huh? Yeah, nothing. There's 3. Yeah, 3 goes into 3 and 12. So, but instead of just taking out 3, see what they're saying? Factor out a negative. I'm going to take out negative 3. When the front is negative, take out whatever you take out in common as negative. Good there. So I take out negative 3. Put a parenthesis. Now, what goes on the inside?
X plus 4.
Yeah, negative 3 times what would go back to negative 3x. Well, that's easy. That's just x. And negative 3 times what would go back to careful on the sign here now. Negative 3, negative times what goes back to negative? Positive, huh? Positive 4. Negative 3 times positive 4, huh? See how when you factor out a negative? Let me write that for you. When factor out a negative, the GCF, right? There's negative. The signs change inside. All signs change inside, don't they? You see that? It changes the sign. Why? Because that's what's true. That's the only way it's going to go back. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. That goes back. Like that. We good there? Questions on that? No questions. Term is negative. So whenever the front one's negative, take out whatever you take out for the GCF, but take it out as negative. So I'll give you a second to do that. Okay, so let me jump in and give a little bit of help. As you look at the three of these, let's do the number first off. What number goes into, what's the greatest number that goes evenly, here, let me make it bigger. I think we need it a little bigger. Negatives, what is it, 16a to the 7th plus 12a to the 6th and minus 4a to the 5th. Okay, so what's the biggest number that goes into 16, 12, and 4? 4, yeah, because 2 goes into all of them, huh? But the greatest number is 4. Now, when I take it out, I'm going to take it out as negative 4 because the front is negative, right? Now, remember what we do for the letters. What letter do we take out? We take out. Remember me and Shelby and GCF, and I would say, what do you do for powers? When you have a bunch of powers on a letter, let me look back with you. Maybe that would help. It's not going to be A. Look back here for a minute. It's been a while since we've done one. Yeah, all these it's been a while. Yeah, no, I'm not helping very much. There we go. There's one. It's been a long while. Look back here to number 2. When we had x cubed and x squared, what did we take out? The lower one. Remember, you take out the lower power because that's the greatest amount they share. Right? I said if Shelby had 3 coins and I had 2, the greatest amount we both have is 2. Right? It's the lower power. Yeah, so it's going to be, yes. So you always take the lower power. That's the greatest amount they share in common. So you're going to take a to the 5th. Is that making sense? So you take the lower one. That's the greatest amount they have in common, huh? They all have at least a to the 5th, don't they? Some of them have even more. But that's the greatest amount they all have in common. They all have at least a to the 5th in them. So you take the lowest power. Now, take it from there. Just put inside whatever works. So we're going to have 3 terms for whatever works there. Minus 4a to the 5th times, go back to this. Yeah, 4a to the 2nd, right? Because 5 and 2 will add to be the 7. Is that good so far? Out front numbers multiply, powers add, don't they? So minus 4 times 4 is minus 16. The powers add to be 7. Next one, the plus 12. Going to be minus 3, right? A to the 1st, or just regular A. Is that good? Because again, out front numbers multiply, powers add. Negative 4 times negative 3 is plus 12, powers add. All right, now the last one. Oh, just plus 1, huh? Because it's got to go back to be the same. There we go. Is this making sense? Tracking with me? So when we do the GCF, we find the biggest number that goes in and take the smallest power. Because that's the greatest amount they have in common. Right? We good? Okay, so they want me to factor. What do they even say? 4 term by grouping. Factor by grouping. Okay. New kind of factoring. It's related, but slight change. So we're going to factor by grouping. And so how are we going to do that? We're going to look at this thing and we're going to say, well, let's just say what we've already been saying. What do they all have in common? Let's just start there. What do they all 4 have in common? Yeah, nothing but 1. We don't have, everything has 1, so we don't even do anything with 1. Yeah, they don't all have an X, do they? The 9 doesn't have an X. The 3Y doesn't have an X. They don't all have a Y. A couple of them don't have Y. So they don't all have a number, because there's no number on the 3rd term here. The XY is just a 1. Really. There's nothing. There's nothing in common to all 4. You with me? They don't all have an X, they don't all have a Y, they don't all have a number. Well, then what are we going to do? Grouping. Now, what does grouping mean? It means because they can't all four have anything in common, we're going to do a 2-2 deal. First two, last two. First two, last two. The first two, so just do the first two all by themselves. Because you can't, there's nothing common for all four. So just do the first two. Go ahead and do them right over here. Just pretend the whole problem is just those first two. Just 3x plus 9. Forget about everything else. Just do the first two. What comes out of just those first two? What do they have in common? Yeah, 3, huh? Leaves. What goes inside? 3 times x, 3 times 3. Good so far? That's just the first two. Now, bring this plus sign down. He's important. That's in the middle. Now, do the last two. So what do these two, just those two, have in common?
Y.
Yeah, they both have a y, don't they? All right, good so far? Y times what? We'll go back to xy. X and y times 3. We good to there? So I just did first two and last two. Okay, now, can we stop right here? Are we done?
No.
No, you can never, let me give you something to help you know when you're done, when you're not. You can never leave a plus sign or minus sign loose, meaning not contained in parentheses. Look back to the answers we've got. So see how all the pluses and minuses are contained? Well, then there's that one, but he's just in the front. He's not between two things. See how that works? See how the pluses and minuses are always contained? So we can't stop that plus sign that's loose. He's right in the middle. He's telling us not only that we're not done, but how to look at what's left to do. He's separating the terms into those two like that. So pluses and minuses outside of parentheses, like this one, separate things. They're the separate. They're like the commas that separate parts of sentences, right? They're like the commas in the algebra language. So anyway, what do we do now? So, okay, great. This term, that term. What do they have in common?
X plus 3.
They both have an x plus 3. Remember, this is what I said we'd see again. Like what if somebody, just to bring your eye into focus in case you're having trouble seeing it, I'll say it's like 3w plus yw. What would you do if you had 3w plus yw? You'd say, well, they both got a w. Take it out, 3 plus y, right? Well, same thing here. It's just a bigger thing. They both have a parenthesis x plus 3. Take it out, remove it. What's left over in the other parenthesis? 3 plus y. Just like we did there. Done. There it is. How do we know we're done? All the pluses and minuses are contained. There they are. Does that make sense on that? Questions on that? So when you're done, all the pluses and minuses should be contained. They're like horses. Do you guys know horses need to be contained? You guys know anything about horses? I know more about, well, I don't know much, but I have 2 daughters that have loved horses, and I've, suffered financially under horse love. Yeah, horses are crazy to your bank account. Anyway, one time I was holding the horse, and my Lizzie daughter said, I didn't hold it. She handed me the rein. I'd never even been on one of the things, and I just held the rope. She said, "Hold the horse, Dad. I got to go do da 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 da." Well, she left. The horse jerked its head, and pulled the rope away and walked out of the little gate thing. It's a 1,000-pound animal. I'm not going to stop it, Lizzie comes back. "Dad, you let go of the horse?" "Well, he yanked his head." "And you let him out of the corral? He's just going to run." I'm like, "Oh, is that bad?" So yeah, I learned that day. You don't let him out. So plus signs and minus signs are like horses. You got to keep them corralled, and you're not done until they're all corralled in the end. It's got to be in the parentheses, then you're done. So you always know you're not done if you got loose pluses or minuses. Try this one. This will be a lot like the last one. So factor that one. So do what we did last time. First two, last two, right? Start with the first two. See what they have in common. Then do the last two. Let me show you. All right, so first two, last two. This is called grouping. 2-2 split, right? Two groups. All right, so those first two, what goes into those first two? They both have an m, don't they? You take the lower power, m to the first, regular m, right? What does that leave? M times what would go back to 5m cubed? 5m squared. And m times what would go back to 6mn? 6n, huh? Good so far? Plus, yeah.
Couldn't you just rewrite it?
Natalia, right? What's that, rewrite it?
Couldn't you just rewrite it so that you could?
Let me show you that in a minute. I'll show you. Okay, plus, now, keep that in the middle. What do the last two have in common? Nothing. So let me write a note about that. When the last two have nothing in common, comma, factor out a 1. Because you got to have something to factor out because you're trying to do the 2-2 split thing. So just take out a 1, right? 1 goes into everything. Everybody has 1 in common. That good? I mean, 1 times 5m squared, 1 times 6n. Yeah, that's certainly true, isn't it? You can always take out a 1. You see what I mean? We good there? Now, can I stop here? Am I done?
No, you're not.
How do I know I'm not done? The horses are running free, right? Pluses and minuses loose, not corralled, tells us we're not done. And that also tells you how to look at it. So if you're moving into higher algebra now, this is the brink of intermediate algebra. This is where intermediate algebra begins. So you want to start, you're going to get bigger and more complex expressions. You want to know how to look at them. The pluses are and the minuses are the separators. That's how you should visualize it. That loose horse tells you you're not done, and he separates them. And you say, oh, okay. Looks like they both have a parenthesis, 5m squared plus 6n, don't they? So what do we do when these two big terms have something in common? We put it in the front. It's what they have in common, a parenthesis, 5m squared plus 6n. Remove it. New set of parentheses. Bring down the leftovers. What's that? M plus 1. Done. All the horses are contained, corralled. We're done. Good? Makes sense on that? Now, let's check it. You don't even write this down, but let me show you. Let me show you it's really true what we're doing. I wouldn't write this down, but how would you check it to see if it's really right? Yeah, FOIL it, because we're unmultiplying, so just multiply it, see if it's right. Boom, boom. Let's see. 5m squared times n. What's that m. What's that going to be? Yeah, the powers add, right? 5m squared times 1. It's just 5m squared, and then boom, boom. 6mn or nm, it doesn't matter what order you put them in. Plus 6n times 1, just 6n. See how it went back? Switch the order around a little bit, but the order doesn't matter. Yeah, is that what you were saying, Natalia? Is you could switch the order like that?
Yeah.
Yeah, that would work too, and then you would, it might be a little smoother either way.
Yeah, you take both the 6s and then...
Yeah, put the 6s together and the 5s together, yeah. But it's right. Either way, it's right and it's good. Make sense? What we're doing is unmultiplying things. Factoring. Super useful in higher math, used to do all kinds of science. All right. Questions on that one? Let me write it a little bigger here. So number 12, 3x cubed plus x squared plus 18x plus 6. All right, try that one. Same kind of thing. We're going to do the 2-2 factoring. So these two, what goes into both those two? Yeah, you got to take the lower power. You don't just do x. Is that making sense? I saw a lot of people just doing x. You guys getting the hang of this? I'm sure you will. We'll go. That's why I'm going real slow, and then we'll redo it again. Well, I don't know if we'll do it next time. We'll be doing practice time, but maybe a little bit again, and then for sure the week after we'll go over this again and again and again. You get better and better. Yeah, when you have two of them, you always do the lower power. So not just x, but the lower of the two, which would be x squared. Okay. Now what goes inside? Whatever works. That'd be 3x plus 1, right? Good so far? Now let me just tell you what you're expecting. Whenever you do this 2-2 kind of thing, 4 terms, 2-2, you see this parenthesis 3x plus 1? This better come up over here too, or I did something wrong. So if you want to just like help yourself out, you know there's going to be a 3x plus 1 over here.
Always?
Yes, always. Always when you're doing 4 terms. Always when you're doing 4 terms, it'll be a 2-2. Well, when I say always, I mean always in our little homework section because they're making them nice that way. Not always in the real world when they do engineering and science and all kind of physics and things are hard. Things don't always do that. But I'm telling you, for now, they're going to give you nice ones that will always do that. So yeah, so that's what I mean by always. Always in this homework assignment. Yes. So good so far? It's going to match. Well, then how do you know what goes in the front? Well, what goes into 18 and 6? Well, 2 does. 2 goes into 18 and 6. 3 does. But what's the greatest thing that goes into 18 and 6? 6. Remember, you got to get the biggest number. 6. And that works, right? 6 times 3 is 18. 6 times 1 is 6. And see how they match? Is that good? Can we stop there? Are we done? No, we got this loose horse. Got to do another step. So then you know what to do, right? What they have in common, you put in the front. Remove it. Start a new set of parentheses. X squared plus 6. And we're good. We're done. Is that making sense? How are we doing? This getting more comfortable? Questions I can answer? Okay. So first 2. So what do the first 2 have in common? What are they both? Yeah, first off, numbers. What number goes into 6 and 12? Well, 2 does. 2 goes into 6 and 12. 3 goes into 6 and 12, but the greatest thing that goes into 6 and 12 is 6. We're taking out the greatest amount we can that's in common. Okay, so we got the number 6. Now, when it comes to letters, what letter do they both have in common? They both have X, don't they? And you take the lower one, the plain X, huh? So 6X. Do they both have a Y? No. So we don't take out any Y in common. They don't both have Y. All right, what goes on the inside? Whatever works. 6X times what would go back to 6X squared? X. And 6X times what goes back to minus 12XY? Minus 2Y. Good there? So far, so good? Now, we know what to expect over here, don't we? X minus 2y is what we're expecting. Let's see. What do they have in common? What goes into 5 and 10? 5. And the front is negative. So remember, whenever the front is negative, the front of the back two, I mean, the front of the group at the back is negative. Negative 5. Is that right? Minus 5 times x is minus 5x. And minus 5 times minus 2y? Sure enough. Plus, right? 2 negatives multiplied to be positive. Do we see that? Negative times negative is positive, huh? Good to there? Okay, now, can we stop there? Because we have the loose horse, right? So we got to keep going. The minus sign right there outside of parentheses. So keep going. What do these two terms both have in common? They both have an x minus 2y. And so remove it, start a new set of parentheses. What's left inside? 6x minus 5. Done. This getting easier? Getting the hang of it? Questions I can answer there? No? That's good? All right. Okay. Let's try this one. I get so focused on the 2, 2, 2, 2, do the 2, 2. Remember, I forgot that we're really supposed to look and first ask the question, what do they all four have in common? From the beginning, before we do any breaking them up into 2, 2. What goes into 12, 18, 8, and 12?
4.
2. Excuse me, 4 doesn't go into 18. So 2.
That's what.
2. So you've got to take that out. You've got to put a 2 in the front, like that. Big old parenthesis. I don't know what's wrong with my pen all of a sudden here. Come on, pen. So 2 in the front. And then what goes, so if there's something in common to all 4, you have to do that. They haven't given us one like that up to this point. So what does that leave from there? 2 times what would go back to 12x squared y? 6. Hello, 6. X squared y minus, and 2 times what? 9 x squared. And 2 times what? Minus 4y. And 2 times what? Whoops. Just messed everything up. Plus 6. See that? They all have 2 in common. Now, go back to the normal business. Now, from here, do the first 2 and the last 2. That makes sense? This is a harder one.
Keep the 2 in the front.
The 2 must be in the front in the very end. What I would probably do, because it's kind of weird having the 2 in the extra parentheses and all that, I would probably just bring the 2 down and go, okay, I know there's a 2 in the end. It's going to be part of the answer. And then just deal with the rest of the stuff like normal. Does that make sense? It's an extra hard one. So these get fairly complex. This chapter 6 has got a little complexity to it. Everybody see that first step? We had to take out what went into all 4 of them. What they all 4 had in common. 2 goes into all of them. So now, what I've found is that often that 2 in the front confuses people. So let's do this. Let me just erase it. Pretend it's not there. Kind of helps you to look at it better. It will be part of the final answer. I've already got it, down here. It's part of the final answer. Now, just do what we've already learned on the part that remains. What have we learned? Okay, well, what about these 2? What goes into 6 and 9? 3. 3, not 2. Right, 3. And what letters do they both have in common? X squared. Right? That good? Parenthesis. What goes inside? Whatever works. 3x squared times what? And you're going to have a minus sign here, and then times what? 3x squared times what? Goes back to this? 2 and y, huh? 3x squared times 2y makes 6x squared y. And 3x squared times what goes back to 9x squared? Just the 3, the minus 3. Good there so far? Now, remember when you find this parenthesis, you know you're going to have the same thing back here every time in this little homework section. Right? What goes in the front? What do 4 and 6 have in common? 2. And the sign that's in the middle must come straight down. Minus 2. Is that right? Let's double check it. Minus 2 times 2y? Minus 4y. Minus 2 times minus 3? Plus 6. Perfect. It's working perfectly. Now, can we stop there? No. Got a loose horse. What do? We put 2y minus 3. Remove it. New set of parentheses. Bring down the 3x squared and the minus 2. And finally, that 2 that came out in the first step, put him in the front, and there's your answer. He does go in the front at the very end. He's part of the answer. That's all you got to do is pop him in the front. Was that your question, Jesse?
Yeah.
Just pop him in the front at the end. Did you get the fly?
Almost.
Oh.
It's driving me crazy.
Yeah.
There's 2 of them.
Use the buddy.
Oh.
They're having a party.
Is that good? That one's not easy, is it?